photosynthesis, the fundamental chemical reaction for life on Earth. The fact that plants take sunlight and are able to turn almost 100% of it into energy makes it possible for all beings to exist. We've tried to copy it with solar panels, but the rate doesn't even get close. So, how do they do it? And most importantly, why is it so efficient? The process happens in thylakoids. They contain chlorophyll, the molecule that is responsible for it. Now let's see it a little better. The chlorophyll molecule has a magnesium atom in its middle that has only one electron on its valence layer. Now let's see what happens when we throw light at it. So, when light hits the atom, the photons take the electron off, and the hole in which it used to be behaves as if it was a positive charge. Now this hole and this electron form what we call an exciton. Now, in order to complete the reaction, the exciton needs to get to the reaction center, and it does it by jumping from one molecule to another.
Or does it? That's exactly where quantum mechanics comes in.
In the quantum world, there's this principle called superposition. It's like what happens when we put a cat inside a box. As soon as we close it, we don't know if it's dead or alive, so we say that the cat is in a superposition of states. The same happens with particles, except the superposition is for the places in which it can be. It's like they're in all places at the same time, with different probabilities of being found in each of them. In this case, instead of jumping randomly, which would probably lead the exciton to get lost and never get to the reaction center at all, it goes through all paths at the same time. This could explain why the reaction is so efficient. But there's a problem. When we open the box, the cat collapses into one state, and so does the exciton. The particle only behaves as a wave until it's measured, and by measured, we mean interact with any other particle. In order to clearly observe this behavior, the experiments must be done in temperatures near absolute zero, otherwise, the chances of it interacting with another particle increase.
So how do plants do it? How is it possible for the excitons to remain unmeasured within room temperature? Well, it's a mystery, but some recent evidence has suggested that it's exactly what happens. They're thrown like waves at the thylakoids and send a pattern of wave interference.
One way or another, what we know is that it happens and it keeps us alive. And perhaps understanding it better, we may understand a lot more about our own existence.